Hello. Over the past few releases, Ixia has been delivering a Netconf test solution in IxNetwork that can emulate both Netconf controller as well as server. This session I'll be giving a brief overview of the entire Netconf test solution that has been delivered so far. I will discuss the Netconf controller emulation first, the different use cases possible, followed by a live demo about how to configure Netconf controller in IxNetwork, and then the Netconf server part will be discussed. Let's begin with the Netconf controller to test a duty acting as a Netconf server. So this is a sample test topology against which we'll be showing the demo. So you can see this. This is the Netconf controller simulated by Ixia, and this is Netconf server. So there are multiple controllers talking to the same server. So Ixia can simulate both the scenario where these controllers are different controllers talking to a server, or this can be a single controller but having multiple sessions with the Netconf server. This is a small screenshot of how the Netconf controller looks like in the IxNetwork. So to change the number of Netconf controllers, one have to just change this device multiplier here. So here 10 controllers have been configured, and this can be changed according to the test need. So now let's go over to the different use cases possible. So one thing, the very one is, first one is whether the DUT SSH Netconf compliant or not. So we offer different SSH login mechanisms like username password based, key based, no authentication, ports are configurable, and then one very important useful feature that we have provided is to show decrypted Netconf packets. So by default, the Netconf packets, if you capture, they are SSH encrypted, so the payload of the Netconf is encrypted. One cannot make out what's going on between the client and the server, whereas we can show the capture in a decrypted manner, where this payload portion will be decrypted, and as per the Netconf protocol, you can see that some RPC reply is there within the payload portion, so which normally will be encrypted and not visible to the user. So this is a very useful debugging tool to see what's actually being exchanged between a Netconf controller and a Netconf server. Next, uh, to measure the duty's capacity to handle multiple command snippets in bulk. So from IxNetwork, we can configure huge number of XMLs, each XML having Netconf requests of different type like get config, edit config. All those commands are written in XMLs, and those XMLs are sent out by IxNetwork. And these XMLs are basically young model agnostic, so user can have his own young model. He just has to give input to IxNetwork in the form of XML. The body of the XML can be as per the young model that the duty supports. So it's totally agnostic. Ixia doesn't bother about the type of the young data model that is being used by in the test case. Next is the duty response time. So Ixia can measure how much time the duty is taking to respond to certain request messages. So Ixia will be sending request messages and receiving the reply from the duty, and we can measure the time difference between the request sent and reply received. So that's how we can show user the response time. These will come as min, max, and average response time per session. We can show them. Okay, so now let's go through the demo. Whatever we have discussed so far, let's show how to configure Netconf to achieve those use cases. So we have this Netconf controller configured here. I have just configured single Netconf controller. This is the multiplier changing which we can configure multiple controllers. So I have only one controller right now, so the server IP has to give here, and then command snippets. This is the command snippets, where how many number of command snippets one wants to configure. So command snippets are nothing but the number of XML files, and these XML files in turn has the different Netconf commands like get config, edit config. Those commands are there in these XML files. So these XML files will be given as an input. This is the directory where the local machine directory where the sample these XML files should be stored. And then we have some capabilities in the Netconf configurable. Then in SSH we have different type of authentication mechanism available, and in the debug we have this decrypted capture. If it is enabled, then the capture will be captured, and I mean the packets will be captured and shown in decrypted manner. And then we also save all the reply XMLs that are coming from the duty in a particular port. We all, save all those XMLs for a for post processing. And there is a log cleanup facility as well here. If these XML files are eating up huge amount of memory in the client machine, there is a mechanism to clean up with a particular frequency, configurable frequency. Now let's start the protocol and see what's going on. And one more thing, on the command snippets data there is a transmission control, so one can decide how the XML files should be sent out. So I have currently kept it as 2-second transmission, continuous transmission with a 2-second frequency. Let's start the protocol. Okay, we see some warning error here which says that 2 out of 2 files not found. So what it is saying here is that whatever XML files I configured over here, command snippets, they are not present here. So I have to configure something that is there. I mean the XML files need to be there in this directory which were not there. So let me see this netconf. Yeah, doesn't have these sample files over here, so I have to gives these XML files which are here, and you can just quickly go through what is there in the XML files like interface IP config. So this is a sample structure of an XML file. So here we are trying to configure the IP address on the duty. So this is how an XML file looks like, and this is as per netconf base 10. So this is the young model according to which we have written these XML files. Now let me give the correct names over here. Okay, so I have rectified the XML file name, and PDUs have started flowing through. So now if I do a capture, we can see the decrypted packet capture. So get decrypted capture. So we can see a packet capture, and the SSH payload portion is decrypted, and we can see that this is this edit config. Some IP addresses is getting configured, and so that's how the IP address, yeah, so this IP address is getting configured on this particular interface. So we can see what's actually going inside the packet, but a normal capture this will not be possible. Now I will give a quick configuration tips when someone wants to configure a huge number of command snippets over here. Let's say I have just given 10, so it can be more than 10. So giving the name of the XML files one by one in these individual rows is very painful. So we have a solution for this. So user once have to write a CSV file like this, directory name, XML name, and then using this file, CSV file, we can actually populate these XMLs and directory this command this columns. So let me see how we can do that. So I'm going to the command snippet file and file option over here, browse. So as in netconf command snippet XML, open CSV, and yeah, so after selecting this CSV file, then we have these two columns. So I'm selecting XML name. Okay, so yeah, so all the XML names that are there in the CSV file is pasted here, so user won't have to write it one by one in individual cells. So similarly the directory also can be imported. So this is a very useful tips how to configure the multiple snippet files. Now I will demonstrate another very useful feature that we have developed, which is auto generate XML. So these XML files that you are giving as a input here, so somebody has to write those XMLs as per the Young module. So we have a kind of auto generate, a mechanism to auto generate the XML file based on Young module that the DUT is supporting. So how we can do that is we have to go to Netconf client. Let's first start the protocol. So there is a fetch schema info. If it is enabled, so then after protocol is start, the duty, I mean, Ixia will be asking some schema info that the duty is supporting. Schema infos are different Young modules that the duty supports. So we can see those fetched schema information that we got from the duty by this get learn schema info. Once we do this learn schema info, we can see that these are the number of these are the different Young modules that the duty supports. So you can see huge list, and from this list we can just whatever Young module we want to configure XML as a command snippet, we can choose that. Let's say IETF IP. So I choose this particular Young module and I want to generate some XML. So I can choose what type of XML I want to generate, whether get XML, get config, or edit config. If I do get XML, so whatever parameters are defined in this particular Young module, all those will be converted into a get XML file. I mean a XML file where under get command all those IP all those parameters will be written down. The XMLs will be automatically created. So let's see how we can do that. So this XML will be stored in the schema output directory, which is netconf debug. So netconf debug, under debug there is this client. So if there are multiple clients, so for each client there will be a client server combination. There will be separate directories, debug directories automatically created. These are auto created when the netconf starts. So these are the results of different runs. So the latest run is this one. Inside this I have the server reply and Young module. Under server reply all the reply files are stored, and Young modules, these Young modules this IP. So I have fetched the I mean generated XML from this particular Young module, and this is the get XML that gets generated. So we can just see what is there inside. Yeah, so it generates a get of all the IP parameters that is defined in that particular IP Yang. So this is how an XML can be auto generated based on whatever XML I mean Yang module the duty supports. So this is also a very useful feature that will automatically generate the XML, so user won't have to write write manually. Last but not the least, if someone wants to configure multiple sessions between the same controller and duty, then one has to configure this stack multiplier. So if I want to configure 3 sessions between the same client and server, so three netconf controller, same netconf IP, but 3 sessions and in with the same server. And in this each session I can configure whatever XML I want to when user wants to configure as per the test case need. So this is how it can be configured. So here is the end of the first part, which was the netconf controller emulation part. Next we'll see how the netconf server can be configured and the different use cases. So let's see what are all we support on the Netconf server side. So I have taken a back-to-back topology here. On the left-hand side, configured 2 Netconf controllers talking to the same Netconf server. So this Netconf server has 2 sessions over which it is talking to these 2 different controllers. On the Netconf server, we have some similar configuration as Netconf client, like these IP addresses, the port numbers. These are all configurable, and then include RX timestamp in reply messages. So this is one feature where the reply messages that we send from the Netconf server in response to the request messages that we receive from the controller, we can put the RX timestamp in the reply message when the request was received by Ixia. Similarly, we have capabilities over here, same as client. Then SSH also, again, different username password can be supported on different sessions of the same controller, same server. On the debug, we have this decrypted capture facility. And then as a server, what we do is we basically, whatever request comes from the controller, we send a reply message, and this reply message can be uh, can be mixed with okay reply or erroneous reply, and that percentage of erroneous reply is configurable. Let's say, yeah, if we send 100 reply messages, out of that how much will be erroneous reply, that can be configured. Let's say if I configure 50% of the response that we sent from the server is erroneous, and then we can configure the different error types that will be putting inside the response message. These error types are all as per the Netconf RFC. So these are the different error messages, error conditions that we can put in the response message. We also have certain right click triggers, like if user wants to stop sending RPC reply. I mean, DUT is sending request, but from the server there are no RPCs replies going on, so that can be done. Stop RPC reply, and then the RPC can be resumed on a trigger basis, and then we can on the RPC reply itself can be erroneously constructed, like the RPC reply with wrong message ID or with wrong character count. All this kind of different negative test scenario can be simulated to test the controller. Okay, so I've started the protocol, and we offer certain statistics on the server, like the normal per port statistics, how many PUTXRX is going on. So this is an kind of PDU error TX, since I had configured 50% to be erroneous. So as per that, the TXRX are happening, and then we have certain per session drill down. So per session will be effective when there are multiple Netconf servers configured. Here we have configured single Netconf server with multiple connection. So we have to do drill down per connection. So if I go to drill down per connection, this is the per connection statistics. So what's going on in each connection with the controllers. So we see that these TXRX, PDU TXRX statistics there, and we also there are some time statistics that we offer, which is what is the frequency with which we are receiving packets from the controller. So this is basically minimum inter request RX time interval. So this gives the controller an idea how quickly he is sending the packets, and we can see that these numbers are increasing. Yeah, these are changing. So this is drill down statistics, so it's not live, we have to refresh the statistics. So this is how the statistics that we have on the server side. So this is pretty much all that I had to show for both Netconf client and server, the overall Netconf solution that Ixia has. So it very much encompasses both the controller testing as well as the server testing. So that's all from my side. Thank you.